All right, ladies and gentlemen, we are going to be going over complementary angles. Complementary angles. Now, I am aware that some of you have already gone over this one. If you were here yesterday and you did this with us, go ahead and skip over it. Or watch it again if you need a little bit more review, if you're still confused. It's totally fine. Remember, the definition of a complementary angle is the sum of two angles is 90 degrees. So we're going to start by creating a 90-degree angle. So I created my line, and then I found my 90 degrees, lined it up, and then I traced it back. Remember that these need to be rays. These need to be rays. Now, complementary angle is the sum. So we do need an angle that intersects it. So I'm going to create a 40-degree angle that intersects this. So we have a 40-degree angle and a 50-degree angle equaling our 90-degree angle. This is an example of a complementary angle. A non-example would be if I had a similar situation with this line intersected, but it's a straight line. So this line right here equals 180 degrees. Therefore, it is not a complementary angle. Now if we move on, if we split 90 in half, half of 90 is 45. So if we have two 45-degree angles, line it up, mark it, connect it, label it. Make sure they're rays. That's one 45-degree angle. I'm going to create another one. Mark. Line it up. Connect it. Make sure it's a ray. I put it a little too high up, it crosses my other one. But it still makes a 45-degree angle. 45 plus 45 is 90. Now these ones are not connected, but they do equal 90 degrees. All right, the next one we're going to look at, we see that we're going to take a look at an angle that's smaller than a 45-degree angle. I made an angle that is 20 degrees. I'm also going to make an angle that is 70 degrees. Make sure we have a ray. $70 plus 20 is 90. It could have been 75 and 15. Any way that 90 is dispersed, as long as it's two angles added together, the sum, we have a complementary angle. You could also just see it in a normal number form. One example would be if we did 88, an 88-degree angle and a 2-degree angle. Now the 2-degree angle is very small, but the two angles added together equal 90 degrees, so it does work. Now we already have one non-example over here. Some other ones are if we had two 90-degree angles. If we have two 90-degree angles, that actually equals 180 once again. So I'm going to line this up. connect it. And connect it. Two 90-degree angles. The sum of those is 180 degrees. Now also, if we had angles that were crossed, if we had two lines I'm going to measure this really quick. So I have a 119-degree angle. I already know that that is more than 90 degrees, and there's no way that angle, or this angle, the sum of this plus this is going to be 180. The sum of this plus this is going to be 180. And if I have them across, those are either going to be less than or more than. So none of them are complementary angles. And another one would be if we just saw the normal numbers. Numbers like 63 and 26. We see 63 and 26. Those are not complementary. They do not add up to 90 degrees. The next one we're going to look at is adjacent angles. Adjacent angles. Once again, some of you learned this one yesterday, some of you did not. If you still feel confused on it, please watch it again. If you are not confused, you may move on. Some examples of adjacent angles. Even if we don't have angle measures, if we have something that looks like this, using my straight edge here to get some straight lines, I want you to do the same. We have our rays, even though we don't have measures. I did not go through and measure out these angles. This is still adjacent. These two angles share a vertex and they share a side. The shared side and shared vertex are what make these angles adjacent. If we looked at one that were two lines that intersect in the middle, with angle 1, angle 2, angle 3, angle 4. Once again, we do not know what these angle measures are, but I can still tell you the adjacent angles. The adjacent angles are going to be the ones that share a vertex and share a side. So I know looking at this, they all share a vertex, but that does not mean that they are all going to be adjacent. So this vertex in the middle is shared by everyone. But this angle right here, angle 1, and angle 2, they share a vertex and they share a side. So angle 1 and angle 2. Now, if we continue going this way, we see that angle 2 and angle 3 share a side. So angle 2 and angle 3 are adjacent. You can also see that angle 3 and angle 4, they share that vertex in the middle just like all the rest of them. But angle 3 and angle 4 share this side right here. So angle 3 is adjacent to angle 4. I can also see that angle 4 is adjacent to angle 1. They share this side right here. So angle 3, angle 4 and angle 1. 4 and 1. These two right here. So they all share that vertex in the middle, but then 1 and 2 share this side, 2 and 3 share this side, 3 and 4 share this middle side, and 4 and 1 share that one. So there are 4 sets of adjacent angles when we have 2 lines that intersect. Now, if we don't have 2 lines that intersect, but we still have them all coming off of the same vertex. So if we have a shape that's kind of like a Y, something that looks like this, they all have the same vertex in the middle. And remember that we can name angles with letters. So right here I'm going to say this is point A, B, point C, and this vertex in the middle is D. So the sides that are going to be the same, there are a few of them in here as well. So the sides are going to be adjacent. We're going to have angle ADB and angle, remember that's the angle sign, that's not an L, and angle BDC. Now, angle BDC also shares a side with angle ADC. And then our last one on this example side, we have this angle, the ADC, in BDA. ADC, BDA. They share that vertex, that D that's in the middle. Notice all of them do, because they all intersect in the middle. But then it's just a matter of the different angles, and we name the different angles. All right, some non-examples that we're going to look at are if we have 2 that do not intersect at all. So if we have 2 angles that don't even touch each other, doesn't matter the angle measure, remember? If they don't touch, those are not adjacent. They don't intersect at all. They do not share a vertex, they do not share a side. They don't even share a point at all. All right, and then if we looked at one that was also in the same cross form, if we had the same one, The ones that are straight across from each other are the ones that are not adjacent, because even though they still share this vertex in the middle, they do not share a side, therefore they do not match. In their definition. Angle 4 and angle 2, angle 1 and angle 3. Those ones are the ones that are straight across from each other and are not adjacent. And even if we do have two right angles that never ever ever touch, they will not be adjacent. That would be another non-example. Right, we are now going to move on to vertical angles. Vertical angles. Remember that vertical angles are angles that are straight across from each other. Straight across from each other. Great. So if we have two lines that intersect in the middle, even if we don't know the angle measures, we can still determine which ones are vertical and which ones are not. We can see here that angle 1 and angle 2, they share a vertex. They do share a vertex, and they're directly across from each other. So angle 1